All right, good morning, everyone. Welcome to our second to last lecture for the semester. It's winding down, hang in there. Last week of classes, and it's crazy. You got this. Let's do it. Today, we're going to jump in and cover the respiratory system. We wrapped up the endocrine system on Friday, and we've got about a day and a half worth of lecture on the respiratory system. So let's see what that looks like for today. We're going to start off with a review game called Name That Endocrine Organ. Then I'm going to start in lecturing on the respiratory system. Includes a video on how respirators work. We've heard, or ventilators, excuse me. We've heard a lot about ventilators in the news, especially the past couple, 3 years or so. Short video on that, and then more on the respiratory system. We'll wrap up with some reminders and a schedule. And at the end of class today, I didn't have it on here, but we have quiz number 6. And we'll do that at the end again. I think that worked out better logistically last time. That way, when you're done, you can just take off. Before I jump in, what questions do you have about what's going on? All right, let's play the game. Name that endocrine organ. Go ahead and scan the code there. And you'll see a series of questions. As best you can, try to answer the questions without consulting your notes. If you've exhausted your knowledge and need to look at your notes, that's fine. But this is a good kind of way to assess for you and for me where you're at. Jay, go ahead.
The names are wrong.
Oh, okay. Hold on one second. Yeah, I might have put the wrong QR code in there. Hold on one second. I think I might have not updated that QR. Sorry. I reused it from last year and select your name as it appears in the class list. Oh, weird. Hold on one second. All right, I'm going to pause this recording. All right, go ahead, try that. It should work. Is it working okay now? Everyone good? All right, let's go ahead and question number 1, or I guess question number 1 and 2. It's a good review for the quiz too. All right, question number 2. Question number 3. And question number 4. That's the last one. You go ahead and submit it. And then I think, actually, I wasn't planning this, but I think we'll go back then and just answer all these to make sure you've got a good understanding. This will be useful for your quiz for sure. When you're done, just go ahead and set your phone down, and then I'll know you're done. All right, let's go ahead and just quick review. Just shout out, what are these? Adrenal glands, good. And what's their primary role involved in what? Stress response and more broadly, energy balance. Yeah. So remember, we have the cortex produces glucocorticoids and neurocorticoids, and those are involved with long-term energy balance. And then the medulla is associated with the sympathetic nervous system. There we have your adrenaline produced, norepinephrine and epinephrine, and those are responsible for that short-term stress response. What's this guy? Thyroid. What does it do? Yeah, it regulates metabolism throughout the body. And that's the gist of it. What's this guy? Pituitary, its primary role. Yeah, kind of everything, right? It involves energy regulation, stress response, reproduction, you name it, basically, in the anterior and posterior pituitary together play some role in regulating those systems. So you can think of it as the master regulator. And what's this guy? Pancreas, what's it do? Yeah, what are the two primary hormones it produces to regulate glucose? Insulin and glucagon, yeah. So, all right, good. That's the big pieces I want to make sure you know where these structures are, what hormones they produce, and their general role. Questions on any of that stuff? Or anything else relevant to what you'll see in your quiz today? Yeah, Gio. That's correct. It only covers what we talked about through last Wednesday. So you should know where all of the endocrine organs are, although we didn't get to the specifics of most of them until Friday. So I won't ask you too many. So I guess some of this is more specific than you'll need to know for your quiz. Yeah, good. All right, let's talk about the respiratory system. So the respiratory system is the system that allows us to move air in and out of our body, and specifically our lungs, so that we can exchange gases. That's the general gist of it. The gases that we exchange, of course, are bringing oxygen into the body and releasing carbon dioxide that are necessary for respiration at the cellular level. Or oxygen is necessary at the cellular level to produce ATP, to perform all of these various functions of our body. And CO2 is a byproduct of those reactions. So we need to get rid of it. And so when we talk about the respiratory system, I want to think about respiration involving 4 distinct processes that all work together to allow this to happen. The first of that is pulmonary ventilation. This is probably what you think about when you think about the respiratory system. This is the mechanical act of moving air in and out of their lungs, so inhaling and exhaling. We then have something called external respiration. So this is the exchange of those gases between the air and, between the air in the lungs, in the alveoli, and the blood of those alveolar capillaries. And we'll see that on a smaller level coming up. But generally speaking, this is when those gases are exchanged across those thin membranes in the lungs. Now that oxygen is in the blood, we need to move it around the body. And that is part of the process. That's the job of the circulatory system. And that is the transportation of those respiratory gases. So specifically, oxygen moves from the lungs to basically every cell in your body. And then once that oxygen gets to those cells and those tissues that need it, we have something called internal respiration, which is the movement of O2 and CO2 between the capillaries in your body tissues. So we've got to bring air in and out of the lungs. Once the air is in the lungs, we can exchange gases between the air outside and the blood via those capillaries of the lungs. We then move those gases around the body. Specifically, we're bringing oxygen from the capillaries of the lungs to everywhere else. And we talked about that. And for example, in lab last week, we talked about the circulatory system a little bit, primarily focusing on the heart. And then once that oxygenated blood gets to the tissues where that oxygen is needed, that gas exchange has to happen there. So those are 4 steps that are important for respiration. Now, to make these steps happen, I want to walk you through the major organs of respiration. We're not going to get into a lot of the physiology involved with these processes. Rather, I just want to talk about the major anatomical structures. So the organs of the respiratory system can be divided into 2 major categories. Before I talk about that, I wanted to go back to the slide and just pause, see what questions you have, not work too fast through this. Make sure you've got those notes to see what questions you have. We're good here? Okay, so the organs of the respiratory system can be divided into 2 major groups. One is the conducting zone. These are the organs that are associated with moving the air into the lungs where that gas exchange can happen, but none of the gas exchange happens here. And importantly, these structures not only move air, but as they do, they perform 3 important processes. And I'll talk more about these, but they filter the air. So they clean junk out of the air that we don't want to bring into our lungs, dust, bacteria, et cetera, et cetera. They humidify the air, so they add water to it so that we don't, it allows our tissues in our lungs to be nice and moist, which facilitates that gas exchange, keeps your lungs healthy, and it warms that air. So there's not, importantly, a direct route from the outside right into your lungs. It's not a straight tube. Rather, it's kind of a series of convoluted structures so that the air can be clean, it can be humidified, and it can be warmed before it gets to your lungs. We want all of that. We want the air that gets to our lungs to be really clean and warm and moist so that the gas exchange can be efficient. And also it's more difficult to get particles out of our lungs once they're there rather than filtering them up through the nasal passageway. And you'll see how that works. Now, once that the air is transmitted or moves through these structures, it then gets to the respiratory zone. This is where this external respiration happens. So this is in the lungs, and this is the structures that have the where we find these structures called alveoli. And that is the site of this gas exchange in the lungs. So we need to move the air through into the alveoli, and then we have the structures associated with the alveoli where gas exchange happens in the respiratory zone. So conducting zone, respiratory zone. What I'm going to do today is start walking through the conducting zone. We won't get through too much of it probably today. We probably won't get to the respiratory zone. We'll pick that up on Wednesday, and that'll bring us to the conclusion of our course. Bum, bum, bum. All right, let's talk about the conducting zone. So these are the structures in order that you'll need to know. I'm going to walk through each of these and show you a diagram, but basically air moves through from your nose to your nasal cavity, to your pharynx, your larynx, your trachea, and then into the bronchi of the lung. And you can see one bronchus here moving up into the trachea. This is a poor choice of a diagram on my part because it primarily actually shows the respiratory zone more than the conducting zone. But that's the gist of it. Actually, let me just move to this diagram. I think will be more helpful. Here is kind of an overview of the respiratory system, and you can follow the path of air here. You can see that it enters through the nostril. It then travels through into the nasal cavity and can move through the paranasal sinuses. We'll talk more about that in a little bit, but remember that nasal cavity has these kind of convoluted passageways that provide turbulence for the air. And that is, there's 2 primary bones associated with those structures. Do you remember what bones of the skull are associated with that? I heard somebody say it. Ethmoid bone. Good, good. Remember, you have the labyrinths of the ethmoid bone, and you have specifically the superior and the middle nasal conchae associated with the ethmoid bone. And then what's the other bone that's associated with those convoluted passageways? Good. The inferior nasal concha. You guys got this, right? Remember, the ethmoid bone has those passageways, and then there's another bone associated with it, the inferior nasal conchae, or there's a left and a right inferior nasal conchae, and that is also part of those structures of the nasal cavity. Remember, that allows the air to circulate. It creates a lot of space for mucous membranes so that air comes in contact with those mucous membranes, and those little particles can be filtered out. From there, the air moves into our pharynx, which I'll talk about in more detail in just a second. Basically, this passageway in the back of your mouth and nasal cavity. And then it moves down into the larynx, which includes your voice box. So that's our site of primary site, I should say, of sound production. Of course, we can produce sound in other places as well. From there into the trachea, and then the trachea then branches into the primary left and right bronchus, or bronchi plural. And then from there, those bronchi bifurcate into a whole bunch of smaller secondary bronchi, which then get smaller and end up terminating in the alveoli. Now, I'm not going to talk about the alveoli yet. Just want to talk about this passageway first. One really thing to note about this passageway is that it's rigid, meaning that it maintains its shape even as pressure changes. So the trachea specifically, you'll see in your cats tomorrow in our dissection, that it's this really rigid tube. It has these rings of cartilage around it. The analogy I might like to make is if you've ever, for example, used one of these paper straws, which are good environmentally, like I get that, I'm not knocking paper straws, but once they get a little wet and soggy, you try to suck out of it and they kind of collapse as that pressure changes. Your trachea can't do this. If it did that, then you wouldn't be able to breathe, and not being able to breathe is bad. That's actually the primary takeaway from this entire unit. Not being able to breathe is real bad. So the trachea and these other structures as well are rigid. Even as air moves in and out, there's some flexibility there, but they generally keep their shape. That way, every time you breathe in and out, that tube doesn't collapse and it provides an open passageway for air. Now, having said that, there's places here, of course, where you can close things up. Specifically, this little flap called the epiglottis I'll talk about, that you want this passageway to be closed when you're swallowing because we don't want to get food down the trachea, because that's bad, and that prevents us from breathing. And remember, not breathing is bad. Good. You guys got this. You're ready for med school. All right, I'm going to pause there, see what questions you have. All right, let's talk about some of these structures in a little more detail. First, I want to talk about the nose. We'll talk about the nose a little bit in lab tomorrow as well, but I want to just orient you to some of the external structures of the nose. Specifically, what these structures you see here, the dorsum nasi is kind of what we commonly call the bridge of the nose. So it's basically, it means the back of the nose here. And then you have the ala of the nose. Ala means wing. And so that's the little flares on the side of your nostrils there. Nostrils are often or kind of more formally referred to as the nares. I'll just call them nostrils, but if you see that term nares, it's the same thing as a nostril. It's the little hole in the front there that air goes in and out. The apex of the nose is the little tip of your nose there. It's where you go boop when you get booped. And then this word is actually from the Greek word for love potion, is this little kind of split in your lip just inferior to your nostrils. And that is called the philtrum, the love potion. I would leave it to all of you to guess why it's called that, but I'll leave it there. So orient yourself to these structures, and they're important. Notice that they are cartilaginous. So as you know, your nasal bones only extend down to maybe about here on your nose, and the rest of this is cartilage. And that provides rigid structure, so your nose doesn't get all floppy, right? But also some flexibility. You can move, you can grab yourself by the apex of the nose, you can wiggle it a little bit, you've got some flexibility there. That way, if someone does boop you, your nose doesn't break. So the nose is important because it provides this passageway for respiration. Sorry, there's a typo there, it should be just a passageway. As I mentioned, when the air enters the nose, it is moistened and warmed and also filtered. And also your nose is important for speech production as well. This is why if you have a cold and you're stuffy, your voice sounds a little funny. That's because part of the vibrations produced as part of speech resonate in the nose. And so when that is blocked or altered, your voice will sound different. And importantly, the nose houses your olfactory receptors, of course, your sense of smell. So lots of important things for the humble nose to do. We're going to get into the internal anatomy more in just a second here, but this is the important structures on the external anatomy. Questions? All right, let's look at the navel cavity in a little more detail. As I mentioned, we have these. Did I have this? Okay, so nares is singular. So you have a right and a left nares. The plural of that is the nares or nares, or nares, excuse me. And so these are the two openings that are divided by the septum, the middle cartilaginous, and then as you get more internal, it's actually bony. But that's the divider between those left and right passageways. This cavity, your nasal cavity, is continuous with the nasopharynx and ends in the back at these structures called choanae. Let me show you that on a diagram in just a second. In the cavity of the nasal cavity is lined with two different kinds of mucous membranes. One is called the olfactory mucosa, and that is at the top, the most superior aspect of the nasal cavity, and that's where those smell receptors are. Remember, those are specialized sensory cells that are associated, or that can sense chemicals in the air, and they deliver that message to your brain via one of your cranial nerves. And just as a reminder, which cranial nerve is that? What number? 1. Yep, exactly. The olfactory bulbs are then transmit information to the brain via cranial nerve 1. In addition to this olfactory mucosa, you have respiratory mucosa. And that is, if you go way, way back in the class to one of the first things we did, we talked about histology, and we talked about pseudostratified epithelial cells. Remember, often these are ciliated, and that's exactly what it is here. And the cilia allow the mucus and associated particles that are accumulated by the mucus to be moved around in your in the nasal passageway. So essentially the air comes in and then is circulated through this nasal cavity where it comes into contact with these two different mucosa. And you can see what that looks like here. So this is a sagittal section of a cadaver. It's a little bit harder to see than a diagram, but I like this figure because it shows you what it actually looks like. We have the superior and middle nasal conchae. These are associated with the ethmoid bone. We have the inferior nasal conchae, which is its own bone. And you can see the air is going in here, and then there's this big old cavity. The nasal cavity is actually really big. At the top here, we have this olfactory epithelium where that air comes into contact with these specialized cells that detect chemicals and deliver that information to us in the form of smell. And then the rest of these this is lined by this respiratory mucosa, this thick mucus that, again, traps particles in the air that we don't want in our lungs. And generally what happens then is that mucosa drains into our digestive system. So we would much, much rather have those particles from the air go through our digestive system, where generally enzymes and high acidity can break those things down and make them harmless, rather than enter into our lungs. Let me see, what else do I want to say here? Oh, just recall here, the palate. Remember, the anterior aspect of your hard palate is formed by the maxilla, the two maxilla bones. And then the posterior part of the hard palate is formed by the palatine units. And back here we have what's called the soft palate, where you still have the roof of your mouth, but there's no bone underlying it. Later on, when you have clean fingers, you can feel the roof of your mouth. And if you feel right behind your teeth, you can feel it's nice and hard. But if you stick your finger a little further back and feel the top, you can feel that it's soft. Don't do it now. Yeah, Kelly. Of course. Get you. Oh, good question. There's not an internal one. It's just referring to the fact that it's where the air enters the body. That's a great question. It's basically the holes. It's the openings of your nose, basically. Mm-hmm. You good, Callie? Awesome. One more point I want to make here. Well, actually, I'm going to reiterate this, is that these nasal conchae, the superior, middle, and inferior, are important again for these three functions. I'm going to say this again to emphasize how important it is. They filter the air, they warm the air, and they moisten the air. So the air comes in, it kind of it experiences this turbulence, so it moves around before it goes back to the lungs, and that performs these three really important functions. What's interesting is that on the way out, they also perform functions of reclaiming some of that moisture before you exhale and reclaiming some of that heat before you exhale. You don't need to give off all of your heat when you move your air out. Although obviously the air you move out is generally warmer than the air that's moving in. We're going to talk about the pharynx next, which you see is labeled here. Yeah, this section just back here. So the air moves through this nasal cavity back into the pharynx. I'm going to talk about that, but I think I'm going to leave that for Wednesday and instead just wrap up with some announcements, and then we've got our quiz. Before I do that, what questions do you have? All right, let me see, where are we here? Did you get your email about course evals yet? All right, look, I made this like super awesome series of slides. Remember, do those, please. It is really important. Make sure you do it for all of your classes. Complete them honestly. I do take that feedback to heart for sure. Just a few reminders here. One is that Danny does have 2 more tutoring sessions this week. Remember, you have a quiz for lab tomorrow on the heart, and he'll be in the lab from 4 to 5 today. Also note, I don't have a notice on this on the slide. Your class program for Wednesday includes reviewing your final lab, which is now available in Visible Body. We'll be covering the respiratory and digestive systems tomorrow in lab. Honestly, my favorite lab of the semester, because we really get to see all the cool insides of the cat, really split it open. So make sure you take a look at that before class tomorrow, will be useful. In addition to his tutoring sessions this week, Danny is going to hold a special session next week, Monday from 3 to 5. Remember, your practical is next week, Tuesday, so this is the day before to brush up and answer any questions you have. I have that information in your class program as well. And remember, the times for the lab practical are in your class program. Half the class is at 8:30, half of it is at 10. So make sure you check those out. And finally, I will have open hours today for the entire 2-hour session that I'm supposed to have normally. Believe it or not, I don't have any crazy meetings that have come up. So I'll be in the lab room today from noon to 2. Just stop by anytime with questions, or if you want to check in about any assignments or anything like that. Sound good? All right, quiz number 6, I will give out now. I'm going to stop the recording of this. If